This video segment is intended to cover the vFlow with iGate Connect and EXM circuit board. This particular product behind me is the Trilogy product, but again, this is specific to the vFlow with iGate Connect and our EXM board. So to start with, one of the best practices you always want to implement, really regardless whether you're doing the flushing or you hire someone to do it, perhaps your looper does it for you, you want to make sure that you're present. You want to make sure that they're implementing the proper procedures as well as protections. One of the critical components, especially on the Trilogy, but as well on the vFlow Connect, because we do have some other components I'll get to in a moment, you want to properly filter that loop fluid. This happens to be a 100 mesh filter bag. It comes into the flush cart that we provide. This again is a 100 mesh. You don't need quite that robust. It could be an 80, that'd be just fine. There are other filtration methods you could utilize, a Y strainer. I've seen some people use pool filters, but make sure that you're taking safeguard and some measures against well, contamination debris that's in loop fields oftentimes. On the Trilogy product in particular, we use a braze plate heat exchanger, and you can see that the water passageways are very, very tiny. It wouldn't take terribly much to impact them, which is going to inhibit the flow. And because it's surrounded by refrigerant, you could actually compromise that heat exchanger and severely damage that unit. The other component that's throughout our vFlow iGate Connect with the EXM board is going to be internal pumping with check valves. It's a spring check valve. It's in the volute of both the hot water as well as the loop pump. So proper procedures to make sure you don't compromise those so that they get stuck and hang open. For this example in this video, we've actually just completed flushing our loop, and that's your typical procedures. If you're uncertain of those procedures, we do have those videos at cmdealernet.com. You're welcome to look at that at your leisure. We go through the flushing of the loop step by step. However, with our vFlow iGate Connect, there are some procedures you need to follow, and I want to illustrate them. But first of all, guys, let me reference that always do flushing on our product with the power off. And if it happens to be the Trilogy, as with this example, you want to make sure that power has been off at least 20 minutes. Don't hurry that. Don't shortcut that, because you won't like the sting and the bite that you get by reaching in next to that high voltage. We have a number of capacitors and an off-board inductor. They pack a wallop, and it takes quite a while for them to discharge. So again, it's important that you make sure that 20 minutes has transpired with no power before you start to tackle anything here on the wet side. So kind of a pre-flush check for the inside of the unit. You may want to consider validating that you have the valve closed on the expansion tank, as well as just make sure that that union is snug. There's also a couple of unions up here on our hot water pump. Again, this is in the Trilogy with hot water product. And then we have a couple of other unions down on the Magna pump, as well as on our Grundfos flow sensor, which we'll reference here in just a short bit. So you may want to consider validating that those are snug, so that if you can prevent some cleanup and making less work for yourself. So now we're ready to flush the inside of the unit, and a few of the procedures we want to make sure you follow. I have our flush cart turned off, and it's really important to notice that I have the return valve going back into the flush cart. That is also isolated. It's shut off from the unit. And the reason this is important is that there are some components inside this heat pump that have some sensitivity to flushing procedures. In particular, in our vFlow with iGate Connect and EXM board, we have a Grundfos flow and temperature sensor. So here's the actual flow body, and then here is the sensor. Here's what the sensor looks like when it's been removed. There's a small diaphragm with a hole here, and that is essentially what is measuring that pressure difference and validating that flow. And the importance of proper flushing techniques is this: we actually have nothing but air inside this unit when you get it. There's a couple things that can compromise this. First of all, if you hit at or exceed 100 psi of pressure, you will probably compromise that sensor. The other one is if you exceed about 30 gallons a minute going through this unit. That will also compromise this, but the one that we have found most importantly that causes the issues with this sensor is not slowly removing that pocket of air. So if you slam that flow from a flush cart full force in there, that wall of water coming in with that air behind it, when it hits that sensor, it actually pops that membrane in there. It's a little bit like someone popping your eardrums, okay? It actually causes the sensor to be then defective, and you'll have to go through a replacement procedure. So it's important to start out with a very modest flow and slowly flood, remove that cushion of air, slowly flood this heat exchanger as well as this flow meter, and get that pocket of air out of there, and then you can open up your flush cart to make sure you've removed all the air. But initially you need to slowly flood this unit and remove that pocket of air from behind the sensor so you don't compromise it through the flushing technique. So now it's time to rotate our built-in vFlow flush ports over to the unit side. Again, I have the flush cart shut off, and I have the return line also isolated on that valve. So now we're ready to go ahead and start our flush cart, but again, when we do this, we're going to gradually and slowly open up our return back into the flush cart tank. And initially, we're going to only hold it maybe, I don't know, 25 to 30% open. The rest is closed, obviously. So again, we slowly flood that heat exchanger as well as that flow sensor to remove that cushion of air. And then once we have pretty much got that taken care of, we can go ahead and open this up and get that air removed out of the inside of that system. So let's go ahead and take care of that. So we're going to go ahead and turn the pump on. Again, our return valve is fully closed at this point, so we're going to power the pump on. Slowly open up this valve to again manage the flow going through our flow sensor and the heat exchanger. We can open that thing up again slowly, getting up to about 25–30% of the throttle. You can hear that air being dislodged coming back into the flush cart. So it's important not to rush this, because quite honestly, getting in a hurry, doing what you're probably used to do, full throttle going through your typical heat pump, well, you're just going to have to go back and make some corrections on that flow sensor, replace the part, and go through this process again. So again, take your time, do it right, save yourself some labor down the road. So I probably have this valve in, I don't know, 40–50% position. We'll go through a couple of deadheading procedures as we normally do to validate whether we have the air removed from the inside of this unit. I'm getting about maybe 1/4 inch drop on my compression test, which tells me I'm good on the air removal. Since I did apply that deadhead procedure, I'm going to go ahead and let it flow a little bit longer, just to make sure I didn't dislodge any air by doing that compression test. And I've got very, very little movement on my fluid level drop when I do that compression test. So now I'm ready to actually do the last step here in the flushing procedure for the inside of the unit. That's I'm going to rotate those valves and actually mix both the loop and the unit fluid together. This is, guys, when you would actually take a sample of your antifreeze level, verify it, don't guesstimate, make sure you're actually using a hydrometer or a refractometer, and validate your amount of antifreeze should you need to add antifreeze in the location that you're in. So we're ready to rotate our internal vFlow flushing valves so that we're circulating through both the loop and the heat pump. Again, making sure that our return into the flush cart valve is remaining at no more than about 50% throttle. So we're going to go ahead and we're going to rotate these valves. So now that we're actually circulating through both the heat pump as well as the loop field, we can go ahead, because we're not going to be sharing all of that flow through that flow meter inside the heat pump, only partial, we can go ahead and open this up and maximize the flow again with that shared loop field. So again, we don't want to do this full throttle going through just the heat pump, only when we are shared or loop side only. Otherwise you're throttled. Now that we've circulated both through the heat pump and the loop field for some period of time, we're going to go through a couple of compression tests looking for our fluid drop through our sight glass and the indicator. We're using an O-ring on our indicator. That is the only true measure whether we have successfully moved that air out. And remember, guys, got to have at least minimum, absolute basement, 2 feet per second velocity going through that entire loop field, as well as your internal components, to remove that air. You're not going to dislodge the air just by saying, oh gee, I don't see any more bubbles coming back, or I've been flushing for 30 minutes. The only true validation is compression test, fluid drop. So again, I'm going to close this return valve and I'm going to look at my fluid drop. I don't know if the camera will be able to see this. And I'm going to see if I have any air left in there, because air and gases compress, liquids do not. I do have a little bit of flex in my hoses here, which I will allow for. So I'm going to go ahead and set my fluid level, which it is. Deadhead that pump, and I'm experiencing a drop of about 3/8 of an inch, which is fairly satisfactory, to be honest with you. That or less, typically for most flush cart hoses and apparatuses, means that you've got that air out. So at this point, I'm ready to go ahead and deadhead the unit, but there's still another procedure we need to follow. So in this case, because my flush hoses have shutoff valves at the end, which I highly recommend, it's less messy when you go to pull your hoses from the unit. On that return back out, I'm going to go ahead and I'm going to shut that off and deadhead that pump, let it pressurize that system. Now I still have my onboard expansion tank. That valve's been closed throughout this entire process, but there's still air in it and I need to burp it. So I'm going to remove this tire Schrader cap. Again, I want to emphasize, only with the power off, and it's been off every bit of 20 minutes. You don't do anything on the wet side with power on to these units. I'm going to go ahead and I'm going to burp this. Okay, I'm in good shape there. Clean it up, put my cap back on. Now I'm ready to pressurize my expansion tank. Again, my pump is still operating, so I can go ahead and open that valve, which puts a volume of fluid inside that expansion tank, and now I can go ahead and put my flush valves for my vFlow into the service mode, which isolates our flush hoses and makes it a closed system at that point. And now that's complete, we can go ahead and shut our pump off. So that is the procedure for properly flushing vFlow with iGate Connect and the EXM board. And in this example, of course, the Trilogy as well. Again, those important components that we want to protect is primarily the flow sensor. But in case you actually compromise that sensor, well, we're going to shoot a video to show you what it's like to change that sensor. For those of you that cowboyed it up, did it your way, now you get to fix it our way.